Hi guys, so today we're going to talk about reference angles. Now a reference angle is defined as the positive acute angle formed by the terminal side of a non-acute angle and the x-axis. What does that mean? Basically, from where the angle stops, the terminal side, it's the quickest or the shortest distance to the x-axis. And the angle is always going to be an acute angle, which means it's going to be less than 90 degrees. If you get a reference angle that's bigger than 90 degrees, you did something wrong, okay? It's always going to be the quickest distance to the x-axis. So let's take a look. There's four possibilities. If our angle is in the first quadrant, we rotate it from the initial side here. We rotate up, in this case, 45 degrees. So how far from the x-axis did that go? It went 45 degrees up. The reference angle would be 45 degrees because it went up less than 90 degrees. Any angle in the first quadrant is its own reference angle, as long as we're dealing with positive angles. Any angle in the first quadrant is its own reference angle. Now let's take a look at a quadrant 2 angle. So let's say we take 135 degrees. This angle went past 90 degrees, but it's not quite at 180 degrees. Now the reference angle would be this angle in here. The distance between the terminal side, because here's our initial side, and then here's our terminal side. The distance between the terminal side and the x-axis, the quickest way to the x-axis, would be over here to the one where we rotate to 180 degrees. So how far from 180 degrees is 135 degrees? Well, we would take 180 degrees and we'd subtract 135 degrees, and we would get a reference angle of 45 degrees. So it has the same reference angle as the first quadrant angle we found, even though they're totally different angles, but it's still 45 degrees from the x-axis. So in the second quadrant, because we went past 90 degrees but we're not bigger than 180, we say 180 degrees minus our angle theta. That will give us the reference angle. Now if we're in the third quadrant, so we started our initial side here. We rotate all the way around here. It went past 180 degrees. But how close to the x-axis is it? That's like asking how far past the x-axis did we go. So since our angle is bigger than 180, we take 225 degrees and we subtract 180 degrees. And that gives us 45 degrees. That means that this angle in here is 45 degrees. That's the reference angle. So this time we took our angle and we subtracted 180 degrees. Okay? And the last case is if we're in the fourth quadrant. So our initial side is here, and we're going to rotate all the way around past 180, past 270. And the reference angle is how close to the x-axis. Now, since it's how close to the x-axis, we never, ever, ever use 270 degrees when finding a reference angle, because 270 degrees is on the y-axis. We're either using 180, 0, or 360 degrees, because those are the angles on the x-axis. If you're in the first quadrant at 0 degrees, second or third quadrant, you're going to use the 180, and the fourth quadrant, you're going to use 360. So if we rotate it around 315 degrees, how much further do we have to go to get to 360 degrees? We take 360 and subtract 315, and again, we have a reference angle of 45 degrees. So in the fourth quadrant, we take 360 degrees and we subtract theta. So basically, these are the rules for how we find reference angles, and we did this in degrees. It's the same thing if we're dealing with radians, by the way. First quadrant angle, it's still the angle, but if we're in radians, in the second quadrant, it would be pi minus theta. In the third quadrant, it would be theta minus pi, and in the fourth quadrant, it would be 2 pi minus theta. So you can do this thinking in terms of radians as well. That all depends on your comfort level with the fractions. And remember, I told you, doesn't matter which way you do it, but I am going to show you the radian way because some of you might actually change your mind and decide to do it that way. So let's try a couple of examples. We're going to find the reference angle for each angle with the given measure. So the first one here is 250 degrees. So if we start Here's the initial side. Remember, this is 90, 180, 270 degrees. So 250, we're going to be past 180, but not quite to the 270. So this is the angle that we rotated, 250 degrees. So for the reference angle, we want to know this distance here. How close to the x-axis is it? How far past 180 degrees did 250 go? So third quadrant, we take the angle 250 degrees, we subtract 180 degrees, and we get 70 degrees, and that's our reference angle. That's it. Let's try 119 degrees. So 119 degrees, here is our initial side. We're going to go past the 90 degrees, but we're not going to go past the 180. So we're going to be somewhere over here, okay? It's for 119 degrees, and we rotate it this way. Now, reference angle is how close to the x-axis. So we haven't gotten to the positive part of the x-axis there yet. We do the 180 degrees minus the 119 degrees, and we'll get 61 degrees. And that is our reference angle. Now, what happens if I give it to you in radians? So we have a couple things we can do. First thing, let's try it actually in radians. Okay, let's actually think in radians for a change. So here we go. We have, this is 0 radians. Now, if this is 6 pi over 7, the denominator is 7. Half of 7 is 3.5. So pi over 2 is 3.5 pi over 7. And pi, written with a denominator of 7, is going to be 7 pi over 7. Well, if we want 6 pi over 7, that's between 3.5 and 6. So this is going to be in the second quadrant. So here's the angle that we rotated, 6 pi over 7. But we want this reference angle here. So how close is it to the x-axis? Well, in the second quadrant, we're supposed to do pi minus our angle. But pi is written as 7 pi over 7, right? That reduces to pi. But this way we can subtract 6 pi over 7. And 7 pi over 7 minus 6 pi over 7 is 1 pi over 7. And that's our answer. That's our reference angle. Now, some of you are saying, oh, no way am I doing it that way. Okay, so your other option is you take 6 pi over 7 times 180 degrees over pi. Your pi's will cancel out, and you're going to get a decimal. It's approximately 154.286 degrees, which you can see is in the second quadrant because it's between 90 degrees and 180 degrees. Then you would have to take 180 degrees and subtract your 154.286 degrees. That's going to give you 25.714 degrees. That is not your answer. If we give you the angle in radians, you have to give us the reference angle back in radians. So you need to now take 25.714 degrees and multiply it by pi over 180 degrees. And hopefully you're going to come up with pi over 7. Now the catch is going to be, don't round those numbers. You're rounding them to write them down. Don't round them in your calculator. Otherwise, you're not going to come out with a perfect pi over 7. So it really is, for this particular one, it really is better if you can do it with the fractions, okay, in radian terms. Let's take a look at another one in radians, okay? So this is 13 pi over 8. So we've got 0 radians. Now pi over 2, we look at the denominator 8. Half of 8 is 4. So that would be 4 pi over 8. For pi, we take the denominator 8 and we make it 8 pi over 8. Okay, we're going to 13 pi over 8, so we didn't get there yet. Now, you take this 4 plus 8 is 12 pi over 8. That's the same as your 3 pi over 2. Just like 1 plus 2 gave us 3. All right, and now, so that's 12 pi over 8. We're still not at what we want, 13 pi over 8. We come back over here. All the way around is 2 pi. If our denominator is 8, 8 times 2 is 16, so this would be 16 pi. So 13 pi over 8 is between the 12 pi over 8 and the 16 pi over 8. So the angle we want is in this fourth quadrant. So this is the angle for 13 pi over 8. Now, if we want the reference angle, it's how close to the x-axis. This time we'd be going to the positive part of the x-axis. So it's 2 pi minus 13 pi over 8. But 2 pi with a denominator of 8 is 16 pi over 8, right? Just double the denominator. Minus 13 pi over 8 gives us 3 pi over 8. And there is our reference angle. Now, let's say, all right, you're totally opposed to doing this in radians. So you're going to start with your 13 pi over 8 times 180 degrees over pi. This is going to give you 292.5 degrees. That's definitely between 270 degrees and 360 degrees. So yes, we're in the fourth quadrant. Now you do 360 degrees minus 292.5 degrees, and you're going to come up with 67.5 degrees. Again, that's not your answer. You need to take 67.5 degrees and multiply by pi over 180 degrees. That will give you, you calculate, if you do 67.5 divided by 180, you will get 3/8, and then you have to remember to put the pi back in the top. There's two more I'd like to do with you. First one here is 480 degrees. Why do I want to look at 480 degrees? Because 480 degrees goes all the way around 360 degrees and it's not done. So we subtract 360 degrees. That gives us 120 degrees. So now we know we have another 90 and then not quite to 180. So we're going to be over here where the 120 is. Whee! Now when you try to find the reference angle, don't use the 480. Don't use the 480. You know you already went around 60. You only had 120 left to go. So how close are we to 180 degrees? We subtract 120 degrees, and our reference angle is 60 degrees. And there we go. Now the next one I'd like to look at is a negative angle. So remember, negative angles, we go backwards. So we start here on the positive part of the x-axis. This is our initial side, and this is 0. We go back down, and this is negative pi over 2, but with a denominator of 4, half of 4 is 2, this would be negative 2 pi over 4. Well, we want negative 5 pi over 4, so we went past that. The next rotation would be negative 180 degrees, which is negative pi, and if we want to write this with a denominator of 4, we put it in the numerator also, negative 4 pi over 4. Well, if we went negative 5 pi over 4, we already went past that. So the negative 3 pi over 2, if I write this with a denominator of 4, this is negative 6 pi over 4, right? I multiplied the bottom by 2, so I multiply the top by 2. Well, we're definitely in between these two then, right smack in the middle, I'm pretty sure. So this is negative 5 pi over 4. This is the angle that we rotated, okay? And the reference angle is how far here. Now, here's the thing. We keep talking about the reference angle as the distance. So you don't need to worry about the positives and the negatives, because the catch is distance, you don't have negative distance. So if you look at 5 pi over 4 and 4 pi over 4, that's the pi. How far apart are they? You subtract them, and subtract them in the order that'll give you a positive number. You don't want to do 4 pi over 4 minus 5 pi over 4, because then you have a negative angle. Your reference angle cannot be negative. It has to be positive. So the distance between these is pi over 4, which, by the way, is 45 degrees. Because, of course, if you did this in degrees, negative 5 pi over 4 times 180 degrees over pi, you're going to get negative 225 degrees. And then you take that 225 degrees and you subtract 180 degrees, you get 45 degrees. Catch is, you should have this one memorized, but otherwise you're going to multiply. 45 degrees times pi over 180 is pi over 4. So you will get the same answer. It's just the work is a little different. Okay, so again, I don't care if you work in radians or degrees. It's up to you. They both have their advantages. You're going to pick what works best for you. Okay, remember the reference angle is always a positive angle. It's a small angle between 0 and 90 degrees. And what quadrant you're in determines where it is. You're always going to find the distance to the x-axis, the shortest distance to the x-axis, which means you're going to be using either the 0 degrees, the 180 degrees, or the 360 degrees to do your subtraction. Never the 90, never the 270. You're always going to subtract from 0, 180, or 360. Okay, guys, have a good day.